All right, guys, so starting Unit 10, we're going to begin formulas for triangles and quadrilaterals, formulas for perimeter and area. Something you might want to do to start, turn your do not disturb or airplane mode on. It might be helpful so you don't get distractions as you're working through this. And if you want to pause the video and go download these 10.1 notes from Schoology, please go ahead and do so. Okay, so what I want to start with is area of a rectangle, base times height, or length times width. Two areas we've used a couple times, or formulas for area we've used a couple times this year. So we're going to start with just that basic formula for when we're finding the area of a parallelogram. And we're also going to use the area addition postulate, which states the area of a region is equal to the sum of its sum of the areas of its non-overlapping parts. And that's what this diagram over here is trying to show you. Looks like this figure is made up of either a square and a rectangle or two rectangles, but the area for this entire figure are just the two non-overlapping parts added together. So total area of 25. Okay. If I'm ever going too fast, guys, you can always pause the video. I'm just going to try and work through these quick because the shorter the video, it's a little bit easier for me to upload onto Schoology. Okay. Using that same postulate, we could take this side of our parallelogram, this triangle, and break it off and attach it here at the end. And now you really have something, a quadrilateral that we're a little more familiar with and we know the area formula for. We just moved our height over here. We attached that same triangle down here at the end, and now you just have a rectangle. You have the same rectangle with the same dimensions that I'm outlining here in orange. If we wanted to find the area of that rectangle, we would just use length times width or base times height, and we would have 15 times 8. We would get a total area of 120 inches squared. The point of doing that exercise was just to develop the formula for the area of a parallelogram, which, like you just saw, base times height. And the most important thing to remember here is that base and height are always perpendicular. So you should be looking for right angles where the base and the height meet. That's going to be helpful for when we find the area of a triangle here in just a sec. Okay? And then same thing. Remember, rectangles and squares, we just spent a unit on quadrilaterals. They're also parallelograms, so you can use the same formula. Base times height for a rectangle, base times height for a square, or just remember for squares, base and height are the same, so we could sometimes use side times side or side squared. Okay, I'll do one of these examples with you, and then I'll let you try one on your own. Let's do B together, and then you could try example A on your own. You need to look at this 90-degree angle because that's going to tell you where the base and the height are located. And really, this 30 is not, the 30 is not helping you with any dimensions of the parallelogram. We have the 11 and we have the 34, right? And we can pick one of those two to be our base. The reason we want to pick the 11 as our base is because we have this dotted line over here that's forming a 90-degree angle with that base. It's not forming a 90-degree angle with the 34 millimeters. So the 11 millimeters is going to be our base, and this is going to be our height over here, which we don't have a measurement for. So in order to do that, we need to use what we know about right triangles. We've done a lot this year. When we have two lengths, we can use our a squared plus b squared equals c squared. 34, that's the longest side, that's our hypotenuse, so plug that in for c. B squared can be the 30 or it can be the height, doesn't matter, plus a squared. A will be our height. When we solve here, we get a squared plus 900 equals 1056. Subtract that over, and we get a squared equals 256, and we are going to get a perfect square here. We're going to get a equals 16, or our height equals 16. So when we're plugging that in to find our area, we now have our base and our height meeting at a 90-degree angle. So the area of this parallelogram would be 16 or 11 for our base, 16 for our height, for a total area of 106 millimeters squared. Remember, we've talked about this earlier this year. Area is number of units squared you can fit inside, so squared units when you are writing your final answer. Okay, why don't you guys try A? And the first thing you want to do is you want to find the height. So you can pause this video and go ahead and solve A, and then I'll work it out with you guys shortly. Right, if you were able to solve for the height correctly, you had a 90-degree or a right triangle here. So when you're solving for your height and use Pythagorean theorem, you would have gotten 4 for your height. It's also a Pythagorean triple, 3, 4, 5 right triangle. And now we have a base of 6, a height of 4, because they meet at this 90-degree angle, so our area is just 6 times 4, 24 inches squared. Okay, let's keep moving on. On the next side, finding different measurements for parallelograms and rectangles, as there might be times where I give you expressions. Okay, so for this example, I was giving you an expression for the area. Just plug it into your formula. The area of a rectangle is base times height, just like a parallelogram. So let's plug in our 6x squared plus 24x minus 6. It's okay if you have expression instead of numbers. Equals 3 times h. We are now finding the height. And then you just have one step. We want to get the height by itself. So we're going to divide that 3 over. Height equals 3 goes into 6 how many times? 3 goes into 24. 3 goes into 6 twice. 2x squared goes into 24 8 times. And it goes into 6 2 times. So 2x squared plus 8x minus 2 inches for the height of this rectangle. Okay, why don't you guys try the same thing on D. Pause the video and solve for the base of the parallelogram. That would have been area equals base, we don't know, times a height of 56. So same thing, inverse operations. Divide the 56 over, and you would have gotten base equals, always reduce those fractions, 1/2, or just half a yard for our solution. Okay, we're going to finish talking about triangles and trapezoids, and then rhombuses and kites on the last page. Area of a triangle. Well, I think we've talked about this year. Remember, it just comes from area of a rectangle. So you see our base and our height formula, and then we just cut it in half because half of a rectangle is a triangle. For a trapezoid, a little bit more work. If you rotate this trapezoid and reflect it on its side, and just copy the same exact shape right here. So now we have this base 2 over here, this base 1 over here, still the same height. Now you should notice that you have, if I outline it orange, you just have a larger parallelogram. So if we use that same formula for a parallelogram, base times height, and we plug in our base, which is going to be the 2 bases added together, B1 plus B2, and then we still have our height of h. We have the formula for the whole entire parallelogram, but really we want that area just cut in half. So base 1 plus base 2 times our height divided by 2, and that would leave us with just one of these halves, which is the original trapezoid we started with. So that's why our formula for a trapezoid is adding the 2 bases, and remember the bases are the 2 sides that are parallel in a trapezoid, multiplying by our height, looking for the perpendicular lines with a 90-degree angle, and dividing by 2. So let's try a couple examples down here. For letter A, we were given the area and we want to solve for the base. So that would be area equals 1/2 base times height for a triangle. Plug everything in. 58.5 equals half. Our base, we don't know, so we're going to leave that as B. Our height is 9. We'll put our base back here. And then just solve. Half of 9 is 4.5 times our base. Divide by 4.5. We get a base of 13 inches. Okay, let's try B together as well, and then I'll let you guys try C and D. Finding one of the bases in a trapezoid when you're given the area. So remember, for a trapezoid, base 1 plus base 2 times our height divided by 2. Plug in what's given. 231 is our area. We only know one of the bases, 23. We're solving for the second one. Times a height of 11, because this is meeting at our 90-degree angle, divided by 2. And let's start solving using inverse operations. Multiply by 2. 462 times 11. You can distribute the 11 if you want, guys. It might be easier just to divide it over. You're going to have to after you distribute anyways. 42 equals B2 plus 23. And when you subtract the 23 over, you get a second base length of 19 millimeters. Remember, you could always plug all of these dimensions in and solve for the area and make sure it checks out to get 231. Okay, why don't you guys try C and D on your own? Pause the video, work through these. I'll put the answers up after you unpause. Okay, for C, you needed to use Pythagorean theorem to find B. 20 was not the base. Remember, this is, I tried to help you out by putting a B here. Base and height meet at 90-degree angles, so 20 squared equals 12 squared plus B squared. And when you solve for B, we're going to get 16. And that's helpful because the 16 and the 12 are your base and your height. Doesn't matter which one. What matters is that they meet at 90-degree angles. Again, I can't emphasize that enough. 1/2 16 times 12 will get us an area of 96 meters squared. Meters squared because you're finding area. And then for a trapezoid, add the two bases. Remember, the 9 and the 15 are your two bases because it's the two sides that are parallel. So 9 plus 15 gets us our 24 times a height of 20 divided by 2. 2 goes into 20 10 times. And 24 times 10 was 240 meters squared. Alrighty, let's finish up with kites and rhombuses. So for a kite and a rhombus, this should say, and a rhombus, with diagonals D1 and D2, they can divide it into two congruent triangles, and that's where our formulas are going to come from. So the two congruent triangles would be right here and this green one. Okay. And remember, diagonal is the length from one vertex to the opposite vertex. So if I was finding the area of this blue triangle right here, that would be 1/2 base times height. And we know that the base is this diagonal, D1. So 1/2 diagonal 1. The height is right here. It's half that diagonal. It's half diagonal 2. Okay, and if we simplify this equation, we get 1/2 times 1/2, which is a fourth, times diagonal 1, times diagonal 2, and then we just have to keep in mind that there's actually two of these, right? This blue one and this green one. So we want to take the area of that blue triangle and double it. Multiply this whole thing by 2. And when we multiply 2 times a fourth, we're right back to a half. So our formula for a kite and a rhombus is just multiplying the 2 diagonals and cutting it in half. All right? We have the same thing listed right here. 1/2 diagonal 1 times diagonal 2. So let's try that on these examples, and that'll be it for our notes on introducing area and perimeter of quadrilaterals and triangles. So for A, you want to find one of the diagonals when we're given the area. Remember our formula, 1/2 d1 times d2. So 48 equals 1/2. We're solving for d2. So you can just leave that as d2, or you could put a variable x in there if you'd like. Okay. Multiply this out, we get 48 equals 1/2 times d2. Divide that 8 over. And we get our second diagonal equaling d2 equaling 6 centimeters. Okay, I want to do kind of a trickier one down here, this last one, finding the area of a rhombus, because we just did a kite. And then I'll let you try C and B on your own. I'll put the answers up in a sec. Remember, area formula is 1/2 d1 d2. And we have one of our diagonal lengths right now. We have 14. So you can plug that in for d1 or d2. It doesn't matter. But we're still missing the length of diagonal 2, which is this length right here. Okay? And you need to remember some of your properties of rhombuses to find that length. Remember, diagonals bisect each other. So now this would have a length of 7. They also meet at 90-degree angles. So you should notice that we just formed, I'm going to put X here, we just formed a right triangle, which can help us find that length of X. 25 squared equals 7 squared plus X squared. When you start solving, we end up getting X squared by itself after we subtract the 7 squared over. Equals 576, and we take the square root, we get X equals 24. So if X equals 24, and we know that diagonals bisect each other, this side would also be 24. So the length of the entire diagonal would be 48. And now we're ready to solve for the area. 1/2, why don't we just cut the 14 in half? Remember, you're only multiplying one of those by 14, either the 14 or the 48 by 1/2, not both. We're just multiplying one of them here. And we're left with an area of 336 inches squared. Okay, go ahead and pause the video, try B and C. For C, you're going to need to use Pythagorean theorem to solve for X and Y. And then for B, you have some variables in there, that's okay. That's all right, just plug it into your equation and eliminate where you can. All right, for B, you should have gotten the length of diagonal 2 equaling 8y meters. And then for C, the area of the kite, using Pythagorean theorem, remember these are all right triangles in a kite and a rhombus. This would have gotten you a length of 40, y would have gotten you a length of 12. For a kite, one of the diagonals is bisected. It's a shorter one, so this was also going to have a length of 9. So the two lengths of your diagonals would have been 40 plus 12 and 9 plus 9. And when you multiply this out, you would have gotten 468 feet squared. All right. That's it. I'm going to pause this video. Hope it's not too long. If it is, I'm going to break it up into chunks and upload it onto Schoology under notes, screencasted lectures. And then if you guys have questions, this will be posted on Friday. We will have a chance to meet the following week during office hours, okay? All right, guys, that's all I have for you. Feel free to email me or drop in office hours next week. Thanks.